All right, we're going to look at the stability of this equation here, dx dt equals x log x. Our first job is, as always, to find the fixed points, which is dx dt equals 0, and that implies x log x equals 0. Now, we have to be super careful around here because that implies x equals 1. X equals 0, which looks like a solution because x0 times log, that looks like it should be 0. It doesn't actually work. Or actually, as I should say this formally, as x tends to 0, log x tends to negative infinity. So this thus is undefined. All right, so that's where we'll leave that. We can't replace it by the limit. So yeah, x equals 0 doesn't work. X equals 1, however, that's where log 1 is 0. That's all good. That's 0. So we can draw in our phase line, and we can draw in the point x equals 1. Now we've got to sketch and figure out which side of this has positive derivative and which side has negative derivative. So I'm just going to draw in the x equals 0 with a circle. Now, to sketch this x log x, we know what log x looks like. Kind of looks like this. Right, and we know what x looks like. Right, that's the line x dt equals x, if you like. That's the line dx dt equals log x. What does x log x look like? Well, clearly, as x gets really, really big, these two things multiplied together is going to start to look linear. Right, it's going to start to look like the straight line. So somewhere out here, it's going to sort of look straighter. Right, down near the log, that's where x is approximately equal to 1. So it's going to look like the log. So we're going to go like that. What happens here near the log again, or near x equals 1, we're going to look like log. However, out here where x gets really, really small and log x gets really, really big, what kind of wins? Well, really, really small wins. You've got to kind of turn around. So somewhere in here, there's a turning point, and this function sort of tends back up like that. So that's what the function looks like, roughly speaking, in gray. That's good enough for our purposes. All we need to know is where dx dt is positive and where dx dt is negative. So clearly dx dt is positive here on the right-hand side of the fixed point. Dx dt is negative on the left-hand side of the fixed point. So where it's positive, we draw arrows from left to right. And where it's negative, we draw arrows from right to left. So what we see is that this critical point is unstable. Alrighty.